Download this code from codegive.com, link in the description below. SSIS Performance Tuning, a comprehensive guide, 52 tips and code examples. SQL Server Integration Services, SSIS, is a powerful ETL, extract, transform, load, tool, but its performance can be heavily impacted by improper configuration and design. Optimizing your SSIS packages is crucial for efficient data warehousing and business intelligence. This guide presents 52 actionable performance tuning tips, categorized for easier understanding, along with code examples where applicable. Hardware and configuration optimization *. These tips focus on the underlying hardware and SSIS configuration that can influence overall package performance. 1. Sufficient server resources, CPU, RAM, disk I/O. Ensure your SSIS server has adequate CPU, RAM, and disk I/O bandwidth for the workload. Monitor resource utilization during package execution to identify bottlenecks. Insufficient resources will significantly hinder performance. 2. 64-bit architecture * Utilize the 64-bit SSIS runtime, which can access more memory than the 32-bit version. This is crucial for processing large data sets. Specify the Run 64-bit runtime property in your project settings. 3. TempDB configuration * TempDB is heavily used by SSIS for staging data during transformations. Ensure it's properly sized, with multiple data files distributed across different physical disks. Restart SQL Server after making changes to TempDB. 4. SQL Server configuration, max memory. Properly configure SQL Server's max server memory setting to avoid excessive memory consumption by SQL Server, leaving insufficient memory for SSIS. Use the SQL Server memory configuration tool to determine an appropriate value. 5. SISP server configuration * If using the SISP catalog, review SQL Server's configuration dedicated to the SISP database. Apply the same performance tuning practices as with other SQL Server databases. 6. Optimize disk I/O * Use SSDs or high-performance storage arrays for source and destination data and TempDB. Minimize disk contention by separating log files, data files, and TempDB files onto different physical disks. 7. Network configuration * Ensure a fast and reliable network connection between the SSIS server and data sources/destinations. High network latency can significantly impact data transfer rates. 8. Disable unnecessary services * Stop or disable any unnecessary services running on the SSIS server to free up resources. 9. Power plan * Set the server's power plan to high performance to ensure the CPU operates at its maximum speed. 10. Antivirus exclusions * Exclude the SSIS installation folder, SISP data files, and any folders used for staging files from antivirus scanning to avoid performance degradation. 2. Package design and control flow optimization ***. These tips address the overall structure and flow of your SSIS packages. 11. Minimize data flow tasks ** Combine multiple small data flow tasks into a single, larger task to reduce overhead associated with task initialization and teardown. However, be mindful of memory consumption if combining too many tasks. 12. Parallel execution * Utilize parallel execution within the control flow to improve performance by processing independent tasks concurrently. Use execute SQL task with isStored set to false and use a parallelism hint. Use maxstop appropriately based on the number of available CPU cores and the workload of each stored procedure. 13. Conditional splits * Use conditional split transformations early in the data flow to filter data based on different criteria, directing the data to different processing paths. This avoids unnecessary transformations on irrelevant data. 14 Event handlers * use event handlers judiciously. Excessive logging or complex logic in event handlers can negatively impact performance. Consider disabling event handlers during production runs or minimizing their complexity. 15 Checkpointing * enable checkpointing for long-running packages to allow them to restart from the last successful checkpoint in case of failure. This saves time compared to restarting the entire package. Enable by setting checkpoint usage to always and providing checkpoint file name. Be mindful of the overhead associated with checkpointing. 16 Transactions * use transactions cautiously. While they ensure data consistency, they can significantly impact performance due to locking and logging overhead. Only use transactions when absolutely necessary for data integrity. 17 Execute package task * instead of recreating shared logic across packages, encapsulate it in a single package and use the execute package task to reuse it. This promotes modularity and reduces code duplication. 18 Logging levels * control logging verbosity. Avoid logging verbose events during production runs as it significantly increases overhead. Choose an appropriate logging level that balances performance and the need for auditing. Use SISP logging and configure the logging level in the Integration Services catalog. 19 Containers, sequence containers, for loop containers, etc. Use containers to group related tasks and manage their execution flow. Containers provide better organization and can improve readability. However, overuse of containers can add overhead. 20 Variables * use variables wisely. Minimize the use of complex expressions in variables as they can impact performance. Consider pre-calculating values and storing them in variables instead of repeatedly evaluating the same expression. 21 Expressions * use expressions sparingly, especially complex ones. Complex expressions consume CPU cycles and slow down execution. Pre-calculate values where possible. 22 Delay validation * set the delay validation property to true at the package and task level to defer validation until runtime. This can significantly reduce design time overhead, especially for packages with complex dependencies. 23 Disable validation * for components or connections that are not actively being used. Set the validate external metadata property to false to skip the validation process. 3. Data flow task optimization ***. These tips focus on optimizing the core data processing within data flow tasks. 24 Source component optimization ***. Fast load * use the fastest available access method to the source database. For SQL Server, use the SQL Server native client provider and consider using the fast load option with appropriate tab lock and check _ constraints settings. This requires careful consideration of locking and index maintenance. Important * bulk copy operations can bypass constraints and triggers, so ensure data quality and integrity. Manage transactions carefully. Filters and predicates * push filtering and data selection logic to the source database using parameterized queries or stored procedures. This reduces the amount of data transferred over the network. Use the SQL command object to execute stored procedures. Indexes * ensure appropriate indexes are in place on the source tables to speed up data retrieval. Read uncommitted, nalloc consider using the nalloc hint in the source query, with appropriate caution, to avoid blocking other processes. This can significantly improve read performance but may result in reading dirty data if data is being modified concurrently. Data types * select appropriate data types in the source component. Avoid implicit conversions as they can be inefficient. 25 Transformation component optimization *. Asterisk avoid blocking transformations. Asterisk minimize the use of blocking transformations like sort, aggregate, and merge join, which require reading the entire input before producing output. If unavoidable, optimize their configuration and consider alternative approaches. Asterisk sorted input for merge join. Asterisk if using a merge join transformation, ensure that the input data is pre-sorted according to the join key. Specify the isSorted property on the input path to inform the transformation that the data is already sorted. Asterisk cache mode in lookup transformation. Asterisk use the appropriate cache mode for the lookup transformation based on the size of the lookup table and the frequency of changes. Asterisk full cache. Asterisk loads the entire lookup table into memory. Fastest for small to medium-sized lookup tables with infrequent changes. Asterisk partial cache. Asterisk caches only the lookup values that are found during the transformation. Suitable for large lookup tables where only a small percentage of the rows are matched. Asterisk no cache. Asterisk queries the lookup table for each incoming row. Slowest but suitable for very large lookup tables with frequent changes or when the lookup table is constantly changing. Asterisk synchronous versus asynchronous transformations. Asterisk use synchronous transformations, like derived column, whenever possible as they process data inline without buffering. Asynchronous transformations, like sort, aggregate, merge join, require buffering and can impact performance. Asterisk script component optimization. Asterisk minimize scripting. Asterisk use built-in transformations whenever possible to avoid the overhead of script execution. Asterisk precompile expressions. Asterisk precompile regular expressions or other complex calculations used in script components. Asterisk external assemblies. Asterisk if using external assemblies, ensure they are properly deployed and optimized. Asterisk avoid global variables. Asterisk minimize the use of global variables in script components as they can introduce performance bottlenecks. Asterisk derived column transformation. Asterisk use the derived column transformation efficiently. Complex expressions can slow down performance. Consider pre-calculating values where possible. Asterisk data conversion transformation. Asterisk perform data type conversions as early as possible in the data flow to avoid unnecessary conversions later on. Use the correct data type for each column. Asterisk fuzzy lookup / grouping. Asterisk these are computationally expensive. Use only when necessary and optimize the matching algorithm and threshold. Asterisk cache transformation. Asterisk use the cache transformation to store and reuse data across multiple data flow tasks. This can improve performance when the same data is required in multiple locations. Asterisk term lookup transformation. Asterisk use for fast lookup of values in a predefined list. More efficient than lookup transformation for simple list lookups. 26 Destination component optimization. Asterisk fast load, SQL Server destination. Similar to source components, utilize the fast load option in the SQL Server destination component for optimal write performance. Again, be mindful of the implications for locking, indexing, and constraint checking. Asterisk batch size. Asterisk adjust the batch size property in the SQL Server destination to optimize write performance. A larger batch size reduces the number of round trips to the database, but can also increase memory consumption. Experiment to find the optimal batch size for your environment. Asterisk indexes. Asterisk disable indexes before loading data and rebuild them afterward for faster load times. This is especially effective for large tables. Alternatively, consider using a staging table. Asterisk constraints. Asterisk disable foreign key constraints before loading data and enable them afterward. Asterisk truncate table. Asterisk if replacing the entire table, use the truncate table option in the SQL Server destination component for faster data loading. Asterisk staging table asterisk load data into a staging table and then use a stored procedure to transfer the data to the final destination table. This can improve performance by allowing for more efficient data transformation and loading. Asterisk minimize logging asterisk reduce the amount of logging performed by the destination component. Turn off rows per batch logging and other unnecessary logging options. 27 Data flow buffers and memory management asterisk. Asterisk default buffer max rows and default buffer size asterisk these properties control the size of the data flow buffers. Experiment with different values to find the optimal settings for your environment. A larger buffer size can improve performance for large data sets, but can also increase memory consumption. Default buffer max rows defaults to 10,000 rows, and default buffer size to 10 megabytes. Monitor memory usage carefully. Asterisk engine threads asterisk the engine threads property controls the number of threads used by the data flow engine. Increase this value to utilize multiple CPU cores. However, increasing it too much can lead to contention and reduced performance. The default value is usually the number of CPU cores. Asterisk use appropriate data types asterisk use the smallest possible data types that can accommodate your data. This reduces memory consumption and improves performance. Avoid DT_WSTR, Unicode string, when DT_STR, non-Unicode string, is sufficient. Asterisk column usage asterisk only select the columns that are needed for the transformation or destination. Avoid selecting unnecessary columns as this increases memory consumption and data transfer overhead. Asterisk row sampling asterisk use the row sampling transformation to analyze the data flow and identify potential performance bottlenecks. Asterisk data profiling task asterisk use the data profiling task to analyze the data and identify data quality issues that may be impacting performance. 4. Specific scenarios and advanced techniques asterisk asterisk. 28 Handling large data sets asterisk. Asterisk partitioning asterisk partition large tables to improve query performance and simplify data management. Asterisk incremental loading asterisk load data incrementally instead of loading the entire dataset each time. This reduces the amount of data that needs to be processed. Asterisk data compression asterisk use data compression to reduce the size of the data being transferred and stored. 29 Slowly changing dimensions, SCDs. Asterisk optimize SCD lookups asterisk optimize the lookup transformation used to identify changes in dimension data. Use appropriate caching modes and indexes. Asterisk minimize updates asterisk minimize the number of updates to dimension tables by using appropriate SCD types. 30 XML processing asterisk. Asterisk use XML source sparingly asterisk XML source is generally slower than other sources. Consider alternative approaches like pre-processing XML data using a script task or stored procedure. Asterisk optimize XML parsing asterisk use the most efficient XML parsing method available for your data. Asterisk XPath optimization asterisk optimize XPath queries used in the XML source component. 31 Web service integration asterisk. Asterisk optimize web service calls asterisk minimize the number of web service calls by batching requests where possible. Asterisk asynchronous web service calls asterisk use asynchronous web service calls to avoid blocking the data flow. 32 Script component optimization, advanced. Asterisk implement interfaces asterisk implement interfaces like IDTS component metadata 100 and IDTS input 100 for better performance and control over the component's metadata. Asterisk avoid boxing and unboxing asterisk minimize boxing and unboxing operations in script components as they can be inefficient. Asterisk use string builder asterisk use the string builder class for efficient string concatenation in script components. 33 Parallel data flows, advanced. Asterisk dynamically create data flows. Asterisk create multiple data flow tasks dynamically based on the number of CPU cores or other factors. Asterisk distribute data evenly. Asterisk ensure that data is distributed evenly across the parallel data flows to avoid bottlenecks. 34 SQL Server Agent Job Scheduling. Asterisk schedule during off-peak hours. Asterisk schedule SSIS packages to run during off-peak hours to minimize impact on other workloads. Asterisk monitor job execution. Asterisk monitor the execution of SSIS packages using SQL Server Agent to identify and resolve any performance issues. 35 Hardware acceleration. Asterisk use hardware encryption. Asterisk if encrypting data, use hardware encryption acceleration to improve performance. Asterisk offload processing. Asterisk consider offloading data processing to specialized hardware, such as GPUs. V monitoring and troubleshooting. Asterisk 36 SSIS logging. Asterisk enable comprehensive logging to track package execution and identify performance bottlenecks. 37 SQL Server Profiler. Asterisk use SQL Server Profiler to monitor database activity and identify slow-running queries. 38 Performance Monitor. Asterisk use Performance Monitor to monitor system resources, such as CPU, memory, and disk I/O. 39 SSIS Dashboard. Asterisk create an SSIS dashboard to visualize package performance and identify trends. 40 Extended Events. Asterisk use extended events to capture detailed information about SSIS package execution. 41 Third-party monitoring tools. Asterisk consider using third-party monitoring tools for more advanced SSIS monitoring and troubleshooting. 6. Testing and deployment. 42 Performance testing. Conduct thorough performance testing under realistic load conditions to identify and resolve performance issues before deployment. 43 Load testing. Simulate realistic user load to identify performance bottlenecks under heavy usage. 44 Stress testing. Push the system to its limits to identify breaking points and potential stability issues. 45 Deployment environment. Ensure that the deployment environment is properly configured and optimized for SSIS package execution. 7. SQL Server Configuration, Advanced. 46 Cost Threshold for Parallelism. Adjust the cost threshold for parallelism setting to control when SQL Server uses parallel execution plans. 47 Max Degree of Parallelism, Max DOP. Set the max degree of parallelism, Max DOP, setting to limit the number of processors used for parallel execution plans. 48 Statistics. Ensure that statistics are up to date on all tables used in SSIS packages. 49 Index fragmentation. Defragment indexes regularly to improve query performance. 50 Plan guides. Use plan guides to force SQL Server to use a specific execution plan for a query. 8. General best practices. 51 Code reviews. Conduct regular code reviews to ensure that SSIS packages are well designed and optimized. 52 Documentation. Document SSIS packages thoroughly to facilitate maintenance and troubleshooting. Important considerations. Context is key. The effectiveness of each tip depends heavily on the specific SSIS package, data source, destination, and environment. Measure before and after. Always measure performance before and after implementing any changes to ensure that the changes are actually improving performance. Iterative approach. Performance tuning is an iterative process. Start with the most obvious bottlenecks and gradually refine the package to achieve optimal performance. Data volume and complexity. Consider the volume and complexity of your data. Different tuning strategies are appropriate for different scenarios. Trade-offs. Be aware of the trade-offs between performance and other factors, such as data quality, security, and maintainability. For example, using nalloc might improve speed, but increases the risk of dirty reads. By applying these 52 performance tuning tips and continuously monitoring your SSIS packages, you can significantly improve their performance and ensure efficient data integration processes. Remember to thoroughly test and document your changes. Good luck.